So Alvina's question is available to you. Screen is available.
Yes, sir.
Okay, now please. We have done these questions all. Okay. Using RHS rule, do question number 4.
Okay.
Do question number 4. There is Rima today. ABC's BE and CF are the two equal altitudes of triangle ABC. Using RHS congruency rule. Prove that ABC is an isosceles triangle. Are you solving? Alvina?
Yes, sir. Sir, I'm not able to do it.
This is simple. Let me help you. Okay, wait a minute. So you need to prove this triangle as congruent. It is being given to you. Okay. So here it is being given that BE and CF are the two altitudes of a triangle ABC. So let ABC is an okay. ABC, and these are the two equal altitudes. This is A, this is B, this is C, and this is BE, and this is CF. CF. Okay, and these are the two equal altitudes. Got it?
Yes, sir.
Altitude means that if it is 90 degree, then this will be also 90 degree. If this is 90 degree, then this will be also 90 degree.
Good
Okay.
evening, sir.
Good evening. Okay, both will be 90 degree.
Yes, sir.
Got it? Now, what you need to do here is
Sorry, sir, for being late. Actually, I'm a little bit sick. I'm having fever.
oh, 3 minutes. Okay, beta. So if I'm having RHS, by using RHS means you have to choose one right angle, one hypotenuse, and one side. Okay. So actually, you can prove these two triangle congruent by ABC triangle is an isosceles triangle. If you prove that this side is equal to this side, or if you proved this angle is equals to this angle, means if you proved angle B is equals to angle C, then you will be able to prove this one. Okay. Both of you please turn on your camera.
Sir, sorry, I'm not. Today I will not on my camera.
Why? Why?
Sir, I'm having some time on it.
Try to open it, Rima. Try to open it, beta. Okay. So if we are having that, for example, if you have proved that this angle is equals to this angle, then you will be able to solve this this question. Huh? How will you be able to prove? Let's So first, you can prove these two triangle congruent if this side is equal to this side is given, then you have to take this side, this triangle, and this triangle. But since he's saying that you have to use RHS rule, so RHS rule, for RHS rule, you have to take this triangle, okay, and the red one and the green one, this triangle, okay. Got it? Got it? Now what you will do? You will take in triangle, FBC and triangle BEC. BEC. Okay, FBC and BEC. You will find that since the altitudes are equal, it is being given that they have equal altitudes. So equal altitude means that BE CF, actually CF, yeah, FC is equals to BC. BEC. I have taken BFC, and then I have taken B. Why I have taken B? I have to write the name accordingly. So if I have taken FBC, F, then B, then C, then I have to take ECB. ECB, okay. Then EB. FC will be equals to EB. It is given that the altitudes are equal, and BC is equals to BC, common in both, and this is actually the hypotenuse. For example, this is the right angle triangle. Okay, this is B, this is E, and this is C. If this is right angle, so this will be the hypotenuse. Okay, the side in front of the right angle is considered to be as hypotenuse side. Okay, so this is hypotenuse. Okay, and this is F. This is another side. This is H. Sorry, S. This is a side, and then we have to take the right angle. So this right angle, this angle is actually equal to this angle. It is given to you that these are altitudes. So you will write here that angle in the red one, BFC is equals to, if you have taken B, then F, then C, then CEB is equals to CEB is equals to 90 degrees. So if you have taken BFC, this angle is equals to this angle. Okay, this is 90 degree. This is given, and this is the right angle. Okay, right angle. So by hypotenuse, right angle, RHS, R, right angle, hypotenuse, and S, side. One side you have taken. So by RHS, what you will be able to prove in red one and green one. So this is the red one. Okay, this is FBC, and this is the green one. Green one is this one. Okay, this is BCE. Okay, so you have proved that this angle will be equal to this angle, means the red hole, this angle in the red one will be equal to this angle in the green one. Okay, got it?
Yeah.
Got it? Rima,
Yes,
you
sir.
understood?
Yeah.
Yes, sir.
Okay, now this will be equal. Then you will be able to write this one. Okay, now you write by CPCT. Okay, congruent part of angle B is equals to angle C. So thus, therefore ABC, ABC is an isosceles triangle. Okay, ABC is an isosceles triangle. Note it down. Note it down fast in your copy.
Okay, sir.
So Rima, you are having fever.
Yes, sir. I'm having fever.
Did you take the medicine?
Yes, sir. Just now I took.
Okay. Alvina, turn on your camera. Noted. You are muted, Rima. Yes. Are you saying something?
No, sir, I'm not saying anything.
Okay. If suppose if you have to prove this triangle by SAS rule or angle side rule, then how will you prove? If it has been given to you that the altitudes are equal, okay. So you can also prove these two triangles, okay. You have proved the angles. So if the angles are equal, this is the one way to prove this triangle, okay. Let's check the another way. Have you noted this one, Alvina? Turn on the camera. I'm not able to see whether you are writing or still doing something. Alvina, are you there? Alvina, are you there? She is not. Okay. How can you prove this triangle congruent, sorry, isosceles triangle by using another triangles? You can also prove this triangle congruent by taking A, B, C, it is being given to you, and the only altitudes are given.
Okay.
BE is equals to CF, it has been given to you. So it has been given to you, given that that BE is equals to CF and BE and CF are BE and CF are, you will check that BE and CF are actually what? Perpendicular, are altitudes. Okay. So what is being given to you that these two are equal, means this side is equals to this side. Okay, it is being given to you. This as a whole is equals to this as a whole. Okay. And this side is equals to this side. It is being given to you. Now, and this angle is right angle because it is, these are the altitudes. Okay. So it is being given to you. So what you need to do here is you need to prove, recently we have just chosen this triangle in the previous part and this triangle. We have chosen these two. Now we can prove, and by this, by choosing these two, we have to prove that this angle is equals to this angle. Now we have to prove that this side is equals to this side. How can we prove? By another method. So we will choose different triangles, right, this time. So we will choose this triangle, AFC, AFC triangle. And the next one is this triangle. Okay. So can you tell me that in ABE triangle, which is hypotenuse? Which is hypotenuse?
AB is the hypotenuse.
AB is the hypotenuse. Okay. And in triangle AFC, in the red one, which is hypotenuse? Rima, tell me.
Yeah.
Which is hypotenuse? The side in front of right angle is called hypotenuse side. So in triangle AFC, means the red one, you will have this angle as 90 degree. So this is the hypotenuse. Okay. Got it? But this time you are not going to prove it by using RHS rule. Okay. Why? Because you have to take the hypotenuse and hypotenuse is not given equal to you. So you can prove this triangles, isosceles triangle means by choosing different angle also. But this time the condition is that if in the question it is not being written that you have to prove this triangle congruent, or you have to prove this isosceles triangle ABC as an isosceles triangle by using some other rule. If there is not specified that you are going to use the RHS or ASA or anything. Okay. So what we will do here is we will choose this angle. Okay. So what I'm just going to draw these two triangles separately. Okay. The green one and the red one. So I'm just choosing this one. Sorry, red one. I'm just taking this as a red. So this is the red one. Okay. And the another one is the green one. Green one, I'm just drawing it separately. Okay. Now this is the green one. And this is A in the green here. And in the green, it is E. And this is B. Okay. And in the red one, this is actually A. And this is F. And this is C. You will notice that angle A is common in both red and green. So you will write here to prove what we need to prove. We need to prove AB is equals to AC. But this time we are not using this. We are just practicing this question by our own choice. Okay. Can we prove this two triangles congruent? Okay. Can we prove this triangle, isosceles triangle ABC is an isosceles triangle, but not using RHS rule? This time we are not using the RHS. We'll use some other rule. So AB is equals to AC. We need to prove this one. Okay. Now prove. How can we prove? You will say that angle A and angle in the green one is common in red one. Both angle A is common in both red and green. So you will write angle A is equals to angle A common. Okay, it is given. Now you will notice here that this is 90 degree in the green one. Angle AEB. Angle AEB. This angle. So this angle AEB is equal to angle what? Angle AFC. In the red one, AFC. This one. Okay. So this one is 90 degree. This one here is 90 degree. So here angle AFC. AFC. And that is equals to 90 degree. It is being given to you.
Yes, sir.
Now what is that thing? The altitudes are equal given to you. That this altitude is equals to means this BE, the red line, this line is equals to this line. It is also given to you that BE is equals to CF. It is also given to you. Got it? So since these are given to you, so by angle, side angle, sorry, angle, one angle you have taken, another angle is this one. So two angle, one side means by angle, side, triangle, which triangle? AEB, congruent to triangle A, then you come up to 90, AEB, then AFC. So what you have chosen in while proving these two triangle, what you have chosen? You have chosen this angle, and this side. You have chosen this angle, and this side. What you have not chosen? You have not chosen this side. You have not chosen this side. So by CPCT, these two sides, anything that is left will automatically become equal. So by CPCT, this angle will become equal to this. This side will become equal to this side. Only we need to prove that this side is equal to this side. Means this side, this one is equal to the red of this one, this side. So when AB become equal to AC, so you can write by CPCT, AB will be equals to AC. AB of green will become equals to red AC. And since in triangle ABC, if any two sides are equal, then it is an isosceles triangle. So you can prove thus ABC is an isosceles triangle. Got it? So thus you can prove it. But this time we are using. So if you need to prove this triangle by RHS, okay, ABC and isosceles triangle, then you have to take these two triangles. Then you have to take these two. And if you have to prove this by angle side, then you have to take these two. Got it? Alvina, understood? Okay. So copy this one also. How many class of quadrilateral we have done, Nima? Alvina? 1 or 2?
Sir, one I have attended the class.
Alvina, how many quadrilaters classes we have done? One or two?
Sir, I think true.
Let's
I
check.
don't know.
Okay. Okay, so have you noted this one? Then we shall be moving towards quadrilateral.
Sir, just a minute.
Get fast.
Done, sir.
Done, Rima?
Yes, sir.
Okay. Okay. So let's if the diagonal of the parallelograms are equal, then show that it is a rectangle. Do we have done this question? Hmm?
No,
Okay,
sir, we didn't start doing the questions.
we
You were
don't
just
start.
explaining.
We just
You
explained
were
it.
just explaining.
Okay. So let's write the question number 1. If the diagonals of the parallelograms are equal, then show that it is a rectangle. So for proving the rectangle to a parallelograms, what are the minimum condition that we required? Check in your notebook. We have done this one. That how can we prove a rectangle, a parallelogram to a rectangle? You know that if a parallelogram is going to have equal diagonals, then it is understandable that that parallelogram is rectangle. So we cannot write it. So we will prove another thing, that we will prove one of its angle as 90 degree. So if any parallelogram is going to have 90-degree angle, then we will say that it is a rectangle. So any parallelograms having any angle of 90 degree, then it is a rectangle. Okay. So let's talk about this one. So so if it is given that if the diagonal of a parallelograms are equal, A, B, C, D. Okay. So what is being given to you? That it is being given that ABCD is a parallelogram. ABCD is a parallelogram. So what are the characteristics or what are the features of a parallelogram? Can you tell me, Alvina? That what are the features of a parallelogram?
Sir,
Sir, the opposite two sides are equal.
Hmm. Opposite two sides
And
are equal and parallel. And parallel. Okay. Yes, Rima, where have you gone? Rima, turn on your camera. Okay, so now it is also been given that the diagonals are equal. So it is also been given that AB, sorry, not AB. ABCD is parallelogram. It is understandable, and it is also given that AC is equals to BD. It is also been given. To prove,
sir, just a
yes,
minute. I will rejoin.
Okay. To prove that AB, to prove, what you need to prove that ABCD is a rectangle. Rectangle, okay? Now prove. What you will take in triangle? What? How will you be able to prove that this angle is equals to this angle? If you have proved, Alvina, that this angle D is equals to angle C, and the sum of adjacent angle, opposite angle in of parallelograms are equal, but the sum of adjacent angle is 180 degree. So if this and this angle will be sum as 180 degree, this and this angle will be going to have sum as 180 degree. So how
Yes.
will you be able to prove that angle B is equals to angle C? Sorry, angle D is equals to angle C.
By RHS, but we can take triangles and the triangle AB.
A, yes. A
Triangle AB, ADC and BCD.
and triangle BCD. Very good. Then
Then
what you will
by
get?
AD is equals to BC because
That
they're
is given
parallel.
opposite side of parallelograms.
Uh,
Okay.
and AC is equals to BD
AC is equals to BD. Yes. Why?
because the
It is also
because the
given
right
diagonals are equals. Diagonals are equal. It is given. Very good. And then
and angle D is equal to angle C because
no,
they're 90 degrees.
we need to prove this one. We need to prove this one 90 degree, because if it is given 90 degree, then it is already a rectangle. Why we are not just proving this one? We need to prove. So DC is equals to DC common.
Okay.
So now we have proved this one. So by side, the two triangle will be congruent. I mean, triangle ADC will be congruent to triangle BCD. Okay, now can you separate these two triangles? You can separate this like this way. One triangle is ADC, another triangle is BCD. Okay. So
Yes, sir.
if you have proved that this side is equals to this side is equals to this side, it is given to you, and this is common in both. So by CPCT, this angle will become equal to this angle.
Oh, yes, sir.
So we will write by CPCT, angle D will be equals to angle C. Okay, and now we know that in a parallelogram.
Sir, can I come back in a minute? Just 1 minute. My sister
Okay,
is calling.
okay. Rima, where are you?
Yes,
Are you there?
yes, I'm there.
To turn on your camera. I feel as I'm teaching myself.
No, I feel like I want to throw up. That's why I went. I feel like I want to throw out. That's why.
It? Wanna throw out?
Like I feel like I want to vomit. That's why I went.
Okay. Rima. Okay, we'll if you are not feeling well, you can rest better. Okay. But try to, this is 20-minute class remaining. So try to, you are a brave girl, you can do, enough. Okay. So Rima, now we are just going to have ABCD. It is being given that ABCD is a parallelogram. Okay.
Yeah, okay.
And we need to, if any quadrilateral is a parallelogram, what does it mean? It simply means that this side will be equal to this side, and this
Yeah.
side will be equal to this side. Opposite sides are equal. Okay. So and the diagonals are also given to you, that they have equal diagonals. Means a parallelogram which is going to have equal diagonals, prove that it is a rectangle. So how can you prove it? So first of all, you will take this triangle. First of all, you take this triangle and the green one, this one. Take these two triangle. Okay.
Okay.
So you will see that this side is opposite to this side, opposite side of the parallelogram. So we'll write AD is equals to BC. Why? Why it is equal? Because this is the opposite side of the parallelograms. Opposite side of parallelograms are equal. Understood, Rima?
Yes, sir, understood.
And then it is also been given that the diagonals are equal, means this quadrilateral is going to have equal diagonals. Okay, so this diagonal is equal to this diagonal. So you can write AC is equals to BD. AC is equals to BD, you can write as.
Okay.
And the third thing is this. This you can take that this green line is overlapping the red one, means this DC is common in both. Okay, I'm just making here separate. Separate. Red one is this one and green one is this one. Okay, this is red one. So DC is in both. Okay, DC. So DC is equals to DC common. This side is common in both. This one as
Yeah.
well as this one. Okay, so this is common. So
Yeah.
by side means this side, and this side. Okay, and this side, and this side. So by side, these two triangles are congruent. This red one and green one. So by simplicity, you can say that the red one is going to have this red, means this angle of red one become equals to this angle of green one. Okay, means angle D is equals to angle C. Okay, now how can you prove it 90 degree? So you know that you have to write in a statement that in a parallelogram, the sum of adjacent angle is 180 degree. Is 180 degree. What is adjacent angle?
It's 180.
What is adjacent angle? So adjacent angles
So
are the angles that are in front, are side by side. Opposite are this one and this one. This is opposite. And this one is this one. These are equal. Opposite angles are equal. But the sum of adjacent means if I'm having A, B, and C, D. So adjacent angle means this angle and this angle are adjacent. Okay, this angle and this angle are adjacent. Got it?
Yeah, got it.
Remove the WhatsApp from this here. Okay. So these are two adjacent angle. Okay. So these are two. Alvin, are you getting?
Yes, sir.
So if you have proved that this angle is equals to this angle, so you can write angle B plus angle C is equals to 180 degree. Why? Because it is the property of a parallelogram that oppose the adjacent angle sum is 180 degree.
180.
If this angle and this angle, for example, this line is parallel to this line, and this is a transversal. This side is parallel to this side, so this side will be acting as a transversal. So sum of interior angle is 180 degree. We have this, studied this one. Like if we have these two parallel lines, the sum of this angle and this angle is 180 degree. So similar is this case. If these two lines are parallel and this will act as a transversal, so the sum of interior angle is 180 degree. Okay.
180.
So you have proved that angle B plus angle C is equal to 180 degree. Now you have previously proved that angle B and C are equal. But here this is not B. I think it is D and C. Oh, it is D and C. In our figure, we have A, B, C, D like this. Okay. So let me make A, B. I have made B there. Okay, wait a minute. A, B, C, D. So this is A, B, C, D. So we will prove that angle D plus angle C is equals to 180 degree. Now you can write angle D, and in place of angle C, you can write again D. Why D? Because D and C are equal. So in place of this, again write D is equals to 180 degree. Then write 2 angle D is equals to 180 degree. Then angle D is equals to 180 divided by 2. You can cut it and you will get angle D is equals to 90 degree. Now you have to write the statement that in a parallelogram, if any one angle, if any vertex angle is 90 degree, then it is a rectangle. Note it down. Uh, Alvina and Rima, you are not attending the test. Sorry, assessment test. Okay, after the class, there is a 5-minute assessment test. Okay, so please do that one again. Okay, they will be going to ask you means 5 questions. You have to do that one. These are all MCQs. You have to do that one and you submit the assignment. Okay, we will check whether you are getting something or not. This is a track.
Sir, where is it sent, the test?
It will be provided on your link. Okay, a link will be given to you or it will be on your portal. After the class, it will be always given to you. Okay,
Okay.
Okay.
so do that one. Okay,
Okay.
do this one. Done. Have you noted this one, the previous one, this one?
That, yeah. No, sir. I didn't.
Note it fast. Then
Okay.
Sir, you mean those questions sent in the PDF form? Those questions you're telling?
no. That will be this will be in your app. Okay. So in your app, do you have app in your tab or something? Learnivio app.
Oh, yes. Yes, I have the app, sir.
So if you have the app, then you will be going to have a portal, student portal. Do you have your login ID and password?
Sir, actually, I log in it, but I'm not getting any questions in that. So again, I log out and it's not coming. Now, if I'm logging in also, it's not working it. I don't know
Okay.
what's the problem.
Okay, I will ask the technical team to help you. Okay.
Sir, for me also it's not coming. I got logged out now. I just opened the app, it's showing me to put the username and password again.
Yeah, you have to put then if you have log out, then you have to put it again. Okay. So let it be. Don't worry. We'll help you. Okay. Don't worry about it.
Yes, sir, I'm done
Have
right
you
now.
noted this one
Yeah.
Noted.
and this one also?
That sir, little more, sir.
Do it fast.
Yes, sir.
Okay. Next. Okay, do question number 2. Note the question number 2 in your copy.
Sir, I wrote the question.
Prove that the diagonal of the squares are equal and bisect each other at right angle. So we have to prove that the diagonals of the squares, first of all, they bisect each other and they bisect them each other at right angle. So what we need to prove here, show that the diagonal of the square bisect each other at right angle. Okay. So let's suppose ABCD the square, it is being given to you. Okay, this is ABCD. It is a square and it is being given to you. Okay, Rima, understood? Now what is being given, asked in the question? Show that the diagonal of the squares are equal. First of all, you have to prove that they are equal. Then you have to prove that they bisect each other. And then they bisect at right angle. You have to prove this one also. Three things you have to prove. First of all, they are equal. Second, they bisect each other. And third, they bisect at right angle. Okay. So how will you able to prove that? This question is a little bit means you need to concentrate here. Okay. So first of all, if you need to prove this equal, then how will you able to prove? It is a square. Square means that this side is equal to this side is equal to this side is equal to this side. And this angle and this angle and this angle and this angle are 90 degree. Okay. So how will you prove that? How will you prove AC is equals to BD? Given that ABCD is a square, ABCD is a square. Okay. To prove, first we are just proving that BD is equals to AC. How will you prove? Alvina, tell me, how will you prove?
Sir, I
Tell me.
don't
Hmm? You don't know?
I don't
Take two triangles in which BC and AC is coming. Choose those triangles.
Okay. I like that. Yes.
So ADC and
ADC and
BC.
BCD. Can take triangles ADC.
Alvina, you have given the team is saying that you have done this one. You have done the
But
assessment
here
previously. You
here
have done
it is
one assessment.
one assessment I had done. The
So
number
this is the same thing. You have to do this one again today. Okay. And Rima, you have to log in first. Okay.
Okay.
And then there will be a login and password will be given to you. Okay.
Okay.
And then you have to move into the dashboard, and then class assessment will be there. Okay.
Okay.
Then you have to start that one. This simple.
So, but it's showing till 10th, not 9th. There's 10th, 11th, 12th.
Now this will be
for
9th.
me.
9th it will be showing you. For maths it will be showing you.
Okay.
Okay. Okay. So what is being given to you? ABCD is a square in which so which two triangle you will choose? First tell me. In which
Triangle
triangle ADC and BCD.
Yes, we have done this one. So first of all, we have choose that in triangle ADC and triangle BCD. So how will you, what you will write here? What are the three things that will prove these two triangle congruent?
AD is equals BC.
Yes, AD is equals to BC. Now Rima need to tell me that why AD is equals to BC?
Because AD and B is parallelogram.
No, it is a square. All sides are equal. It is given. So opposite sides are also equal of a square. So since all sides are equal, so AD will be equal to BC. Hmm. Okay, the next thing. This is the first thing. Okay, the second. The second thing.
DC is common.
Okay, DC is equals to DC common. It is given. Third thing. Third thing.
Angle
AC.
ADBC is equal.
AD
BC.
angle ADC.
ADBC are
A-
equal.
ADBC. Yeah, they are equal, but you have to tell me the one angle, na? Which is in triangle ADC and which is in triangle BCD. Which is that angle which is equal in both?
BD, angle BD and angle AC.
Alvina, you tell me.
Sir, it's angle ADC and angle BCD.
Yes, Rima, you don't know how to write the name of a triangle. Let me help you. That a triangle, a angle name is written in 3 words. In 3 words, okay? Got
Okay.
it?
Yeah.
So this is ADC that we have taken this triangle, and this is BCD. Okay. So these two triangles we are talking about, this one, okay, and this one. So we have drawn this one separately. So this angle is 90 degree and this angle is also 90 degree. All angles are equal. So angle D will be equal to angle C. So you write here angle and you have to write in 3 words. ADC. Angle ADC is equals to angle BCD is equals to 90 degree. Okay. So by which criteria these two triangles are congruent?
SS criterion.
SAS. Because you have chosen this side, and angle in between. So when you have side, angle, side, then it is SAS. So by SAS, triangle ADC will be congruent to triangle BDC, BCD, sorry, BCD. So by CPCT, you have not chosen this side while you were proving and this side while you were proving the triangle congruent. You have not taken these two sides. You have taken only this one and this one, and this one and this one. So the remaining side will automatically become equal. So this is the remaining side and this is the remaining side, so they will become equal. So you will write, so by CPCT, AC will be equals to BD. And what are AC and BD? AC is equals to BD. So AC and BD are the diagonals.
Yes, sir.
Thus we have proved that diagonals are equal.
Yeah.
Okay. Now, how will you prove them that they bisect each other? Means you need to prove that this side is equals to this side and this side is equals to this side. If we consider O as a center.
Sir, can you repeat it again?
How will you prove that? How will you prove that this side is? It means we need to prove that now the diagonal bisect. First, we have proved that diagonals are equal.
Your image is stuck, sir.
What I'm saying here that first we have proved that this diagonal. Let me take
Sir,
the.
can you tell a little bit louder? Your camera has stuck. Your image is stuck. I'm not able to.
Okay. Is it still clearly available to you?
Your voice is like it's breaking and your whole camera is stuck.
Okay, I'm just turning off my video. Okay, now is it okay? For some time, I'm just waiting. Okay. Now this diagonal is equals to this diagonal. We have proved this side because we have taken this triangle and this triangle. We have proved these two triangles as congruent. So we have proved that this side is equals to this side. Okay, we have proved that this green side is equals to this one. We have proved this. So since the diagonals are equal, what we need to do here is next. Tell me. If the diagonals are equal, what we need to prove? Now, if we need to prove the bisect means, so we need to prove if they bisect each other, we need to prove that this DO is equals to OB. How can you prove this one? Tell me. How can you prove? Tell me, how can you prove? Almina, do you have any idea? How can we prove that these two angles are equal? These two sides means if you prove that DO is equals to OB, then you can easily prove this one.
Sir, we can divide DB divided by 2, which is equals to AC divided by 2.
Yes, but if it is given that it is a midpoint, then we can prove now. First of all, we need to prove that this side.
Sir, I have no idea.
You have no idea. Yes, you,
Um,
Rima, do you have any idea?
um, the whole it's written that it's equal. So
So choose these two triangles. I'm going to give you here. Okay, just choose this one. Okay, Nabila is Nabila. Okay. So if we are having these two triangles, let's suppose if we are having these two. Okay. And you need to do this one in the homework now. Okay. Let this is a square. Okay. Alvina, you know that if this side is parallel to this side, then this angle will automatically become equal to this one. Do you know this one?
Yes.
yeah.
Yes.
Because it is alternate interior opposite angle. And similarly, if this side is parallel to this side, then this angle automatically become equal to this one.
Yes, sir.
So take, this is A, B, C, D. Okay. Now take triangle this one and this one. This is O. This one and this one. Okay. Got it? Got it?
Okay.
1 and 2. Now you know that here, that since this side is parallel to this side in a square, so this angle will become equal to this angle.
Yeah.
Okay. And similarly, this side is parallel to, means for, we are having first this side, like this angle will become equal to this one. Okay. And similarly, if this side is parallel to this side, so this angle will also become equal to this one. For example, if I'm having this like this way, this angle will become equal to this one. Okay. So you have two angle, means this angle equal to this one and this angle equal to this one. Okay. Got it? And this
Yes.
side is equal to this side. We have also this one. So by angle, side angle, these two triangle will be congruent.
Yeah.
Okay. So by CPCT, this side will become equal to this side and this side will become equal to this side.
Okay.
So they will bisect each other. So we'll discuss this one in the next class. Okay. So that's all for today. Hope you enjoy the class. We'll meet you in the next one. Okay.
Okay. Thank you,
Okay.
sir. Bye.
Bye. Take
Thank
care.
you, sir.
Okay, take care. Hello, dear students. How are you? Ira. No.
Good afternoon. Good evening, sir.
Good evening. How are you? Is I'm audible?
Yes, sir.
How your studies is going on?
It's fine. It's good.
So you are in 9th standard?
Yes, sir.
Okay. So please turn on your camera.
1 minute, sir.
Okay. So yes, Nabila. So may I know that in chemistry, which chapter is going on in your class?
Atoms and molecules, sir.
Atoms and molecules. Okay.
Same, sir.
Okay. Atoms and molecules. So is there any specific topic, chapter or part that you are facing problem in atoms and molecule, or should I start that chapter from the beginning?
I think so. Start beginning.
I think what?
Um,
Should I start it from the beginning?
so for
Yeah.
me, the topic that I have problem with is balancing equations.
Ira, what you're saying? Please pardon. Wait a minute. Let me connect to my headphone. Wait a minute.
Okay.
First of all, turn on your camera. Ira, turn on your camera.
Arya. Yes, sir.
Sorry.
That's fine, sir.
Actually, I have a student whose name is Ira. So I
Mhm.
just used to name her Ira. So that's why I just IYRA.
Oh,
So,
it's okay.
okay.
So,
So Arya. So how your studies going on?
good, sir.
Good. Okay. So should I start with the Nabila? Why are you hiding yourself? Come closer to the camera. Okay, so may I know that which specific topic are you having in your examinations right now? You are going to have means half yearly has been done. So the first two
Yes, sir.
chapters will be in your examination, and in the next exams or the nearby exams, your unit test, you are going to have atoms and molecules. Okay. So should I start the atoms and molecule from the beginning, or should I start any topic that you are going to have?
Um,
Okay, should I start it from the beginning? In the chemistry, I'm just going to teach you only chemistry. Other teachers will teach you some other subjects. Okay. So let's start with that one. Okay. So wait a minute. If I talk about that atoms and molecules, yeah, what are actually atoms and what is molecules? We're going to discuss this one. Okay. Atoms and molecules. You know that according to Dalton, what is atom? Atom is the smallest particle of a matter. Means if you have a matter, anything matter, what is matter? Anything that occupies space and has mass is called matter. Okay. And we have studied that atoms, what is an atom? Atom is the smallest particle of an element. Atom is the smallest particle of an element, and molecule is the smallest particle of a compound. Okay, there are the two types of molecule. One is a molecule of compound and one is a molecule of an element also. We'll discuss this one. Okay, so let's start studying what is an atom. So according to Dalton, an atom and an atom is the smallest particle of matter that that participate in a chemical reactions Okay, so and what are molecules? If I talk about what are molecules, so molecules are the when two or more atoms combine together, chemically combine together. Okay, we're not talking about the physical combination. When they are chemically combined together, then they form a molecule. So what is a molecule? If I talk about what is a molecule, okay, so we'll simply say here that when two or more similar or dissimilar atoms chemically combined together, they form a molecule. Okay. So what is important when two or more atoms chemically combine together? Are you writing this one? Arya?
Sir, I'm taking a screenshot.
No, no, no. Don't take the screenshot. I will check your copy at the end of the class whether you are writing it properly or not.
Okay, sir.
Note it down. Done, Nabila?
Yes, sir.
Done, sir.
Okay. So we are just going to study that we are just studying the molecules. So if we're talking about that, an atom is the smallest particle of matter that participate in a chemical reactions, and molecules, when two or more similar or dissimilar kinds of atom chemically combine together, they form molecules. The molecules are of two types. Molecules are of
Two times.
molecules are of two types. One is homoatomic molecule, homoatomic molecule. Okay, another one is heteroatomic molecule. What is homoatomic molecule? Homo means same and hetero means different. So when similar kinds of atom combine together, similar kinds of atom combine together. Combine together. And heteroatomic molecules means different kinds of atom combine together. For example, if I'm talking about the similar kinds of atom, so for example, H2, O2, S8, Cl2, N2. So these are the when two hydrogen atoms combine together, when two oxygen atoms combine together. Okay. Hello, Sayyed, Zaid, how are you? Is I'm audible?
Yes, sir, you're audible.
Okay, so how your studies is going on?
Yes, sir.
How your studies is going on?
Yes, sir, yes, sir.
Is it well or something better?
No, sir, not many doubts in chemistry.
Okay, so we are just studying the atoms and molecule chapters. Okay,
Yes, sir.
and please turn on your camera. Okay, so we are just talking about this one, that different kinds of atoms when combined together, like two hydrogen atoms and one oxygen atoms, when they combine together, they form a water molecule. one carbon and one oxygen, two oxygen atom combined together, they form CO2, carbon dioxide. Okay. And one nitrogen and three hydrogen, when they combine together, they form ammonia. So these are heteroatomic molecules. These are hetero means different kinds of atoms are there. Got it? And similar means when they are going to have similar kinds of atoms when chemically combined together. Okay. Got it?
Yes, sir.
Yes, sir.
Okay. So what is heteroatomic molecule? When they are having when two or more different kinds of atoms are going to combine. And what is homoatomic molecules? When two
Similar.
similar atoms are going to combine. Okay. So when a chemical reaction is taking place, you know that we have also studied this one in the previous chapter, that what is an element, what is a compound, and what is the difference between a molecule, what is atoms. We have also studied this one in the previous class. So we are just going to study in this chapter that what we are going to study, we are just going to study the chemical combinations, that how when two or more different atoms combine together, then how they are just combining together. And what is happening when they combine together? Is there any change in mass, or how the order of according to which they are just combining? So let's talk about this one. Okay, have you noted?
Yes.
Yes, sir.
Okay, so let's move further. The next one is we are just going to study that laws of chemical combination. Okay, that how the atoms are going to combine together. Okay, and why they are combining together. Okay, so if I'm having this, okay, the first law, there are the two laws only in our syllabus. There are 5 laws, but out of them, we are just going to have only 2. In our syllabus, we are just going to deal with only 2. So first is law of conservation of mass. Conservation of mass. And the second one is law of definite or multiple proportion. Sorry, law of definite.
Proportion.
Yeah, you can write laws of constant proportion. Constant proportion. So it is same. Okay. Okay.
Okay, sir.
So this is same. Law of conservation of mass or law of definite proportion. What does it says? What does this law say? This law of conservation of mass says that whenever a chemical reaction is taking place, okay, so we have some things. For example, if I'm having A plus B, let's write first what is law of conservation of mass says. It says, it states that the total mass before and after a chemical change is conserved, i.e. mass can neither be created, mass can neither be created during a chemical reaction. Zed, are you writing this one in your copy?
Yes, sir, I can.
Don't take the screenshot. I will check your copy at the end of the class whether you are writing or not. Done?
Yes, sir.
Yes, you said done. Okay, what is law of definite proportion says? Okay, first let's deal with the law of conservation of mass, then leave the space there and we will write the law of definite proportion later. Okay, so what I'm talking about, that's what is law of conservation of mass says. It says that the total mass of the reactant is equal to total mass of the product, or we can say that total mass before and after the chemical change remain constant. So if we have, for example, if I'm having hydrogen bonds with oxygen in the presence of oxygen to gives water. So for example, if you have 4 gram hydrogens and it burns with uh, 32 grams of oxygen, then it will give you 36 gram of water. Got it? Zad, where have you gone? Are you there? Zad, are you there?
Yes, sir.
Your camera is not. Have you turned off your camera? Okay. So what is saying that when you have hydrogen gas burns in the presence of oxygen gas, it will gives you water. So when you are going to have 4 grams of hydrogen gas, it burns with 8 grams of oxygen gas, then it will give you 36 grams of water. So you neither can create water nor you can destroy water. Sorry, the mass. For example, it is not so that if you are having 4 grams of hydrogens, when react with 95 grams of this one, then it will gives you. Okay. So you need to check that total mass before and after before is equal to total mass after the change. Okay. So let's do questions on regarding to NCRT from this one. Done? Noted?
Yes, sir.
Yes, sir.
Okay. So if we have this question on your screen, show that this follow the law of conservation of mass. So does this show that this follow the law of conservation of mass? So in a reactions, we have 53 grams of sodium carbonate. So this is sodium carbonate reacted with 6 grams of acetic acid. So this is acetic acid. The products obtained, products were 22 grams carbon dioxide. CO2 is 22 grams plus 9 grams of 0.9 grams water, H2O plus, and sodium acetate. Sodium acetate. So if we have sodium carbonate is 5.3 gram, it is reacting with 22.2 gram of this one. Then it is giving you the, sorry, 6 gram. 6 gram this one, this is going to give you 2.2 grams carbon dioxide, 0.9 gram water, and 8.2 grams of this one. So check whether it is obeying the law of conservation of mass. Is it obeying the law of conservation of mass?
No.
Hmm?
We should add them and see if they're equal.
Yes, you have to add these three, these two, and these three. If you are getting the same mass on the reactant and product side, then they are equal. Z what will we get when we add 5.3 and 6 gram?
11.3.
Yes, it will be 11.3 grams. And you, Arya? What we add, if we get this three, what will get? 2.2,
Okay,
0.
sorry, I was muted. 11.3.
Yes, it will be 11.3 grams. Okay, 22. Nabila, do you get the same
Yes.
answer?
Yes, sir.
So what will we can simply say here that since the mass of the reactant side is the side that this is the reactant side. Okay, this is the reactant side. Before the arrow is reactants, and after the arrow is product. This is the product. Okay, so we will simply write here that since the mass of reactants is equal to total mass of product, thus it obeys follows law of conservation of mass. Law of conservation of mass. Okay, note it down. Done?
Yes, sir.
So,
You also, Zed, noted?
Yes, sir.
Nabila? Noted?
Yes, sir. Yes, sir.
Okay. Okay. So let's start. Now moving to the next part here is shall be moving towards the law of definite proportion or as a law of constant proportion, the next law. But before, okay, let's have a simple question here. For example, if we heat, if we heat sodium, if we heat calcium carbonate, CaCO3, calcium carbonate, Ca, calcium carbonate. When it is heated, it will gives you calcium oxide plus carbon dioxide. Okay. If this is 100 gram, okay, and we obtain 44 gram of this one, then what is the mass of this calcium oxide obtained? If 100